In these examples, we're going to continue to look at prime and composite numbers. Let's read the directions carefully. Determine whether the numbers are prime or composite. If it is composite, we need to show at least one factor pair of the number besides one in itself. If it is prime, we need to show the numbers we tested and the result of our division. So let's go ahead and get started. So when we're trying to determine whether a number is prime or composite, we basically follow the same test for prime numbers that we did in the previous videos. However, as we're doing these tests, if we come across a factor of the number, we can stop, state the factor and the corresponding factor pair, and then we know the number is composite and not prime. Okay? So here, 27, I know that 27 has a factor of 3. 27 is 3 times 9. So I could actually just write 3 times 9 equals 27 and state that it's composite. And you're free to do that whenever you find a factor. But in the videos, I just want to be a little more systematic and see the process we would carry on with. So 27 lies between 25 and 36. So 25 is 5 squared, rounding down. Now, to determine whether 27 is prime, that means we have to check the primes less than 5, which are 2, 3, and 5. So let's take a look. So is 27 divisible by 2? Is 2 a factor? And we can say, no, 27 is not even. So that's a justification for 27 not being divisible by 2. Only even numbers are divisible by 2. Now we can check 3. Is 27 divisible by 3, or is 3 a factor of 27? Let's go to the calculator. You probably know this multiplication fact, but notice if we divide 27 by 3, we get 9 with no remainder. So we could write (3 times 9 equals 27), and therefore conclude that 27 is composite. So the good news is, when a number is composite, once you find a factor, you just state the corresponding factor pair, and then you've shown that the number is composite, because a number is composite if it has any factor besides one in itself. Here we found 2 of them, 3 and 9. Let's try the next one, 83. So 83 lies between 81 and 100, and we round down, and we see that 81 is 9 squared. So to test whether 83 is prime, we only need to check prime numbers less than 9. And that would be 2, 3, 5, and 7. So let's start just like we did before. So is 2 a factor of 83? Is 83 divisible by 2? And the answer is no. 83 is not even. So that's always a nice, quick, easy test. Now we need to check 3. So let's go to the calculator. If we divide 83 by 3, we see that there's a remainder because there's a decimal. So we would say, no, there is a remainder. Okay, so since there's a remainder, 83 is not divisible by 3. Notice we don't have to check 4 because we're doing a prime test. We can check 5. 5 is also an easy one to check. You can use your calculator if you'd like, but the answer will be no, 83 does does not end in 0 or 5. So 83 is not divisible by 5. Now we have one more to check, 7. So I'm going to go to the calculator for 7. 83 divided by 7 is 11 with a remainder because there's a decimal. So we're going to write for 7, no, there is a remainder. So for 83, we've checked all prime numbers that we needed to see if it was divisible by them, and it wasn't. So this tells us that 83 is prime. 83 is prime. Okay, so just a quick overview. 27 was composite. Once we found a factor besides 1 in itself, we could just say, here are the factors, it's composite. Okay, here are 2 factors, you don't even need to find any more if there are any. In this question, when we found or determined that the number was prime, we just need to check up to those factors in the table, and when it wasn't divisible by any of them, and you have to show and state that you checked all of them, it's not divisible, don't just skip them because sometimes they are when you don't think they are, then you could state that the number is prime. Let's look at a few more. So we have 119. Going to the table, 119 is between 100 and 121, which is here. So we have to check prime numbers less than 10. And notice there's just 4 of them. Remember, 2 and 5 are always easy. So 119, is it divisible by 2? We could say, no, it's not even. Now let's see, is it divisible by 3? Well, let's check on the calculator. 119 divided by 3. Notice there's a decimal, which tells us there would be a remainder. So we would say, oops. For 3, no. There is a remainder. Next, we need to test 5. And 5 is always easy. It doesn't end in a 0 or 5. So we can say, no, does not end in 0 or 5. And the last one we need to check is 7. Let's go to the calculator. And look, it is divisible by 7. It equals 7 times 17. So 119 is 7 times 17 is 91. 119. 119. So now we can say, since 119 equals 7 times 17, 119 is composite. Okay. So notice we had to go all the way to our last prime factor to find a factor of 119 besides 1 in itself, but there was one, so that's why you really need to follow this process through to the end. Now let's look at 101. So 101 falls between 100 and 121, so we'd round down. We need to check the prime numbers less than 10, which again is just 2, 3, 5, and 7. So, starting with 2, and we say, no, it is not even. So 101 is not even. Now we can check 3. divided by 3. There's a decimal, which means there's a remainder. So we will write no. There is a remainder, so 3 is not a factor. 5 is always nice and easy. This does not end in a 5 or a 0, so 101 is not divisible by 5. No, does not end in 0 or 5. And again, the last one we need to check is 7. Let's go to the calculator. 101 divided by 7. There's a decimal, which means there's a remainder. So we can write no, there is a remainder. So since we've checked all the prime numbers that we needed to, we can now determine that 101 is prime. Let's highlight our